My name is Professor Rahul Ramesh Thawai. In the last lecture, we have solved one problem on stress-strain-displacement relationship of three noded triangular element. We are going to solve one more problem in this lecture. So let's see the problem. A triangular plate of a size 75 mm into 50 mm into 12.5 mm is as shown in figure. The modulus of elasticity and Poisson ratio for the plate material are 200 into 10 raised to power 3 Newton per mm square and 0.25 respectively. Upon the loading of the plate, the nodal deflections at the node 3 were found to be 0.01552 mm and minus 0.0004 mm in x and y direction respectively. Model the plate with CST element and determine first the Jacobian matrix for xy dash zeta neta transformation. Second, the strain displacement relation matrix. Third, the stress in the plate. So they have given a triangular plate having node 1, node 2, node 3. The distance between node 1 and node 2 it is 50 mm and the distance between node 2 and node 3 is 75 mm. So this is a diagram which is been mentioned in the problem. So let's start with the solution of the problem. So in the problem itself they have assigned the node number. The only thing which we need to do is we need to assign the coordinates to every node. So for that I will assume node 1 as a reference node. So coordinate for the node 1 will be 0, 0. Then location of node 2 with respect to node 1 is 0, 50 and location of node 3 with respect to node 1 is 75, 50. So first we will calculate the Jacobian matrix. Jacobian matrix J is given by, in the matrix, summation of dou ni by dou L1 into xi, summation of dou ni by dou L1 into yi, summation of dou ni by dou L2 into xi, summation of dou ni by dou L2 into yi. So I will call this as equation number 1. Now you know that addition of all the shape functions should be equal to 1. So n1 plus n2 plus n3 is equal to 1. So n1 is equal to L1. So I will differentiate n1 partially with respect to L1. So it is 1. Then I will differentiate n1 partially with respect to L2 is 0. n2 is equal to L2. So I will differentiate n2 partially with respect to L1. So it is 0. Then I will differentiate n2 partially with respect to L2. It is 1. Then n3 is equal to 1 minus L1 minus L2. So I will differentiate n3 partially with respect to L1. So it is minus 1. And I will differentiate n3 partially with respect to L2, that is minus 1. Now I will calculate the first term, that is summation of dou ni by dou L1 into xi. So it is equal to dou n1 by dou L1 into x1 plus dou n2 by dou L1 into x2 plus dou n3 by dou L1 into x3. Now dou n1 by dou L1 it is 1, so it is 1 into x1 is 0 plus dou n2 by dou L1 it is 0 into x2 is 0 plus dou n3 by dou L1 is minus 1 into x3 is 75. So I will get its value equal to minus 75. Next I will calculate second term, that is summation of dou ni by dou L1 into yi. So it is equal to dou n1 by dou L1 into y1 plus dou n2 by dou L1 into y2 plus dou n3 by dou L1 into y3. So it is equal to dou n1 by dou L1 is 1 into y1 is 0 plus dou n2 by dou L1 is 0 into y2 is 50 plus dou n3 by dou L1 is minus 1 into y3 is 50. So I will get its value equal to minus 50. Next I will calculate third term, that is summation of dou ni by dou L2 into xi. So it is equal to dou n1 by dou L2 into x1 plus dou n2 by dou L2 into x2 plus dou n3 by dou L2 into x3. So is equal to dou n1 by dou L2 it's 0 into x1 is 0 plus dou n2 by dou L2 is 1 into x2 is 0 plus dou n3 by dou L2 it's minus 1 into x3 is 75. So I will get its value equal to minus 75. Next I will calculate the last term, that is summation of dou ni by dou L2 into yi. So it is equal to dou n1 by dou L2 into y1 plus dou n2 by dou L2 into y2 plus dou n3 by dou L2 into y3. So is equal to dou n1 by dou L2 it's 0 into y1 is 0 plus dou n2 by dou L2 it's 1 into y2 is 50 plus dou n3 by dou L2 it's minus 1 into y3 is 50. So I'll get its value equal to 0. So I will put these values in the equation 1. So I will get a Jacobian matrix J is equal to in the matrix minus 75 minus 50 minus 75 0. Now next thing which I will calculate, it's a strain displacement relationship matrix, that is B. So for that initially I need to calculate area delta. So delta is given by 1 by 2 into determinant of 1 x1 y1 1 x2 y2 1 x3 y3. So is equal to 1 by 2 into determinant of 1 0 0 1 0 50 1 75 50. So I will is equal to 1 by 2 into, I will get its determinant to be equal to 3750. So I will get the area is equal to 1875. Now I will calculate beta 1. Beta 1 it is given by y2 minus y3. Y2 is 50 minus y3 is 50. So I will get its value equal to 0. Beta 2 is equal to y3 minus y1. Y3 is 50 minus y1 is 0. So I'll get its value equal to 50. Beta 3 is equal to y1 minus y2. Y1 is 0 minus y2 is 50. So I will get its value equal to minus 50. Next gamma 1 is equal to x3 minus x2. X3 is 75 minus x2 is 0. So I'll get its value equal to 75. Gamma 2 is equal to x1 minus x3. So is equal to x1 is 0 minus x3 is 75. So its value is minus 75. Gamma 3 is equal to x2 minus x1. So is equal to x2 is 0 minus x1 is 0. So I will get its value equal to 0. Now matrix B is equal to 1 by 2 delta into inside a matrix beta 1 0 beta 2 0 beta 3 0 0 gamma 1 0 gamma 2 0 gamma 3 gamma 1 beta 1 gamma 2 beta 2 gamma 3 beta 3. So is equal to 1 by 2 into delta, that is area is 1875 into inside a matrix 0 0 50 0 minus 50 0 0 75 0 minus 75 0 0 75 0 minus 75 0 0 minus 50. So I will get its value equal to 1 divided by 3750 into inside a matrix 0 0 50 0 minus 50 0 0 75 0 minus 75 0 0 75 0 minus 75 50 0 minus 50. Now I will calculate the value of stress, but before calculating the value of stress I need to calculate the value of strain, that is E, and strain E is given by matrix B into displacement, that is del. So strain Ex, Ey and gamma xy is given by matrix B into u1 v1 u2 v2 u3 v3. So is equal to matrix B is given by 1 divided by 3750 into inside a matrix 0 0 50 0 minus 50 0 0 75 0 minus 75 0 0 75 0 minus 75 50 0 minus 50 into 0 0 0 0 0.01552 minus 0.0004. So I will calculate strain Ex as it is given by first row multiplied by column. So that is 0 into 0 plus 0 into 0 plus 50 into 0 plus 0 into 0 plus minus 50 into 0.01552 plus 0 into minus 0.0004 divided by 3750. So I will get its value equal to minus 0.00021. Now I will calculate strain Ey as second row multiplied by column, that is 0 into 0 plus 75 into 0 plus 0 into 0 plus minus 75 into 0 plus 0 into 0.01552 into 0 into minus 0.0004 divided by 3750. So I will get its value equal to 0. Now I will calculate the value of strain gamma xy, and it is equal given by third row multiplied by column, that is 75 into 0 plus 0 into 0 plus minus 75 into 0 plus 50 into 0 plus 0 into 0.01552 plus minus 50 into minus 0.0004 divided by 3750. So I will get its value equal to 0.000053. Now I will calculate the stress. So for calculating the stress, there are two conditions. First is plane stress condition and second is plane strain condition. So here I will assume it to be a plane stress condition. So in that case, stress sigma x, sigma y and tau xy is given by E divided by 1 minus mu square into inside a matrix it is 1 mu 0 mu 1 0 0 0 1 minus mu by 2 into strain ex ey and gamma xy. So is equal to 200 into 10 to the power 3 divided by 1 minus 0.25 square into inside a matrix 1 0.250 0.2510 0 0 1 minus 0.25 by 2 into minus 0.00021 0 0.000053. So I will get sigma x is equal to 200 into 10 to the power 3 divided by 1 minus 0.25 square into first row multiplied by column. So that is 1 into minus 0.00021 plus 0.25 into 0 plus 0 into 0.000053. So its value I am getting as minus 44.8 Newton per mm square. Now sigma y is equal to 200 into 10 to the power 3 divided by 1 minus 0.25 square into second row multiplied by column, that is 0.25 into minus 0.00021 plus 1 into 0 plus 0 into 0.000053. So I will get its value equal to minus 11.2 Newton per mm square. Now I will calculate tau xy as tau xy is equal to 200 into 10 to the power 3 divided by 1 minus 0.25 square into third row multiplied by column. So it is 0 into minus 0.00021 plus 0 into 0 plus 1 minus 0.25 by 2 into 0.000053. So I will get its value equal to 0.424 Newton per mm square. So this is the end of the solution. So in the next lecture we will be solving more problems on stress strain displacement relationship for three coordinated triangular element. Thank you for watching the video.